So now that you know how to write Riemann sums in summation notation, here's the most important parts you should remember. The formulas for delta x and x sub I, since we'll use them a lot for the following problems. So the first problem is about turning a definite integral to a Riemann sum notation. The steps we're going to do to solve this problem is, first of all, we're going to determine f of x. Second, we're going to write out delta x and x sub I. And then third, we're going to plug this all in the formula and write it in summation notation. So now our practice problem is determining the Riemann sum notation for the integral from 0 to pi of sine x dx. And our first step is to determine f of x. And from the integral, we can obviously see that f of x is sine of x. Now our second step is to write out delta x and x sub I. And we can use this using the formulas to our right. We know our limits of integration are 0 to pi. And when we plug this in the delta x formula, we get delta x is pi over n. Plug this into the x sub I formula, we get x sub I equals pi times I over n. Now our final step is to write this all in summation notation. So we can take our delta x, our x sub I, and f of x from the previous problem and plug this into the Riemann sum notation for a definite integral. And when we do this, we get the result that's shown. Now we're going to do this process in reverse. We're going to go from a Riemann sum to a definite integral instead. So there are 3 steps to this process. First of all, we're going to figure out delta x, x sub I, and f of x like we did before. The second step, we're going to find the limits of integration. And then third step, we're going to write this in integral form. So the first step for this is figuring out the delta x, the x sub I, and f of x for this. We can look at our analogous Riemann summation notation for this, and we can see that delta x is 5 over n, and x sub I is 2 plus phi over n. And we can also see that f of x is ln of x. Now our second step is to find the limits of integration. And we can find this using the formulas for delta x. So we have delta x equals b minus a over n. So when we plug in what we got for delta x before, we get 5 over n is equal to b minus a over n. So b minus a equals 5. Using what we got for x sub I, we get that a equals 2, or lower limit of integration. So since b minus a equals 5, we can find out that b equals 7. So now we have our 2 limits of integration, 2 and 7, and our function, which is f of x equals ln x. We can write this in integral form, so we have the integral from 2 to 7 of ln x dx.